Welcome back, everybody. Today we are going to talk about geometric probability. Probability is the measure of likelihood that an event will occur, and it's done as a ratio of the event over the sample space. The event is what we're looking for. The sample space is all the events that could possibly happen. So it's what we want to happen over what could possibly happen. Geometric probability is a ratio, event over sample space, that involves a geometric measure, such as length or area. In this video, we are going to focus on geometric probability with length on a number line. In the next video, we will focus on geometric probability involving area. Find the probability that a point chosen at random on PQ, on segment PQ, is going to be on segment RS. So in other words, if we randomly choose a point between P and Q, what is the probability that that point happens to lie on segment RS? So our probability is going to be an event over the sample space. The event, we're looking for the probability that it lands on segment RS. So the event is the length of segment RS. The sample space is everything that could happen, and that's the length of segment PQ. So the length of segment RS, 1, 2, 3, 4, 5, 6. The length of segment PQ, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 over 10. Okay, and that can simplify to 3 over 5 or 60%. So there is a 60% probability that a point chosen on PQ happens to lie also on RS. Okay, find the probability that a point chosen at random on segment PQ is on the given segment. Express your answer as a fraction, decimal, and percent. Now up here we did fraction and percent. We're going to include a decimal here. Okay, so we need an event over a sample space. So event over sample space, in this case, the event is segment RT. So the length of segment RT over the length of segment PQ. So RT is 1. PQ is from -5 to 5, that is 10. Okay, now to write that as a decimal, we could divide. 1 divided by 10 is 0.1. And if we move the decimal 2 places, 1, 2, we have to throw in a 0, and we get 10%. So it's 1 over 10, 0.1 or 10%. So again, here for TS, we need an event over a sample space, and we'll need an event over sample space for all of these. So the event here is the length of segment TS, and the sample space is the length of segment PQ. So TS is 1, 2, 3, 4, 5 over 10. That would be 0.5 or 50%. For PT, the event is the length of segment PT. The sample space is the length of segment PQ. So PT is 1, 2, 3, 4 over 10. Now this one could be simplified to 2/5. The decimal, whether I do it as 4 over 10 or 2 over 5, is going to be 0.4. And I move that decimal 2 places to the right, and I get 40%. And then for segment RQ, event over sample space is the length of segment RQ over the length of segment PQ. RQ is 1, 2, 3, 4, 5, 6, 7. PQ is 10, so that's 7 over 10, or 0.7, and move that decimal 2 places, and we get 70%.